Today we're going to review sequences as functions. We're going to start with arithmetic sequences. So in general, sequences are a list of numbers that often form a pattern, and each number in the sequence is a term. So we're going to try to find a single rule or a function that will apply to every term to find the next term. So here's an example where we need to find a common difference when we're talking about arithmetic sequences. So we're going to add 3 each time. From the sequence, we can find a function that relates this term to the value of the term. So here's an example of what a common function would look like. N is the term number, that is your input, and a sub n is the value of the nth term of the sequence, your output. Here's an example. So we have the sequence -2, 1, 4, and 7, and we also have the recursive formula. So in this case, our difference is 3. We can clearly see from -2 to 1, we are increasing by 3. And we also know what that initial value is. A sub 1 is -2. So our nth term, or the first term, the value of that is -2. For the second term, the value is 1. For the third term, that value is 4. And then the fourth term, the value is 7. We can also plot those points to see what type of equation. So again, when n, or my input, is 1, then my output is -2. When my input is 2, the output is 1. Input is 3, the output is 1, 2, 3, 4. And when my input is 4, 1, 2, 3, 4. My output is 7. 1, 2, 3, 4, 5, 6, 7. So again, I see I have a linear function. What is the third term of the sequence given by this formula? Well, this time I know that my input n, everywhere I put in a term or number, for n, that's what give me that term. So if n equals 3, I just need to substitute in 3 for n to get that value. The value of the third term of this sequence is 32. Geometric sequences. So the formula for a geometric sequence will include a common ratio, or a number that you're multiplying each term by to get the next term. So for this one, it says find the fourth term, a sub n equals a sub n minus 1 times 3. And I know that the first term is -3. So again, my common ratio is 3. That's the number I'm multiplying by. And so now, if I know the first term is -3, I will multiply the next term by 3. -3 times 3 is -9. And that next term, -9 times 3, is -27. And then -27 times 3 is -81. Okay, so that is how I find the fourth term with this type of formula. What is the fourth term of this sequence? And so again, I can use my table and my graph, and I can figure out that the first term is 2. That was given to me. So I will write in 2. The next term, I will take the first term and multiply it times 2. So 2 times 2 is 4. The next term, 4 times 2 is 8. And then the fourth term, 8 times 2 is 16. So I'll put in each value. And again, I can plot this. When my input is 1, my output is +2. Input is 2, my output is 4. When my input is 3, the output is 8. 4, 5, 6, 7, 8. And this time my input is 4. My output is 16. And I can quickly see that this would be an exponential function. I hope that this was helpful.